In this video, we're going to look at the Pythagorean theorem and the distance formula. So to start out with the Pythagorean theorem, that's going to be applied to if we have a right triangle. So that means the one angle has to be a 90-degree angle. And we're going to look at if we call the two sides here that make up the 90-degree angle, I'm going to call one of those side A and the other one side B. And then the side that is opposite of the right angle is the hypotenuse, which is side C. Now, it doesn't matter which one we label A or B, but we know the hypotenuse here, opposite of the 90-degree angle, is typically referred to as side C. And if that's the case, the Pythagorean theorem states that A squared plus B squared is equal to C squared. And of course, there's many ways we could solve this triangle. In other words, if we're given two sides of this triangle, then we can find the missing side. So if we're given sides A and B, we could plug in for A and B and we could find side C. Or if we're given side B and side C, we could certainly solve for side A. But keep in mind, this only works for a right triangle. And again, here we have A squared plus B squared equals C squared, where C is always the hypotenuse. Okay, so it's always the two sides squared added together equal to the hypotenuse squared. So let's take an example here. If I was to draw a triangle here, and we're going to go over 4 on the x-axis, and then we will go up 2. So here we have our right triangle, and again we know this is over 4 and we're going up 2 units. Okay, so if we wanted to, in other words, this point here, this point would be at 4, 0, and this point up here at the top would be at the coordinates 4, 2. And what we want to find here is, I'm going to label this, we have sides A and B, so really here we're looking for what is side C. What is the hypotenuse? What is the length of this going to be? Well, we could certainly measure this distance here and find the length, but we can't really count because this line doesn't match up with our boxes here, so we can't just count and say what the length is going to be. So here we could use the Pythagorean theorem. Again, is A squared plus B squared equals C squared. So in this case, we would plug in for A and B. And once again, it doesn't matter which one we call A, which one we call B, because those are the two sides that make up the right angle. So if we plug in, we get 4 squared plus 2 squared equals C squared. So we would certainly then get 16 plus 4 equals C squared. So that tells us then 20 equals C squared. So now we have to solve for C. Now keep in mind, this is not C. C doesn't equal 20, it's C squared equals 20. So now we actually have to take the square root. So we're going to take the square root of both sides. And when we do that, we need to remember, and I'm going to keep emphasizing this throughout the course, when you take the square root of both sides of the equation here, this is going to turn out to be plus or minus, because the answer we get could be positive or negative because it's being squared. So therefore, if we take the square root of 20, we could break that down. And if you recall how to do this, 20, we could think of this 20 as being the square root of 4 times 5. And I picked 4 times 5 because 4 is a perfect square. And we can take the square root of 4 and we could pull the 4 out front, and that would make it 2, and we're left with the square root of 5. And therefore this is equal to C. So here C is equal to 2 square root of 5. And again, why are we going to use the positive? Well, in this example, we're using the positive instead of the negative because we're talking about a distance. So the distance has to be positive, so therefore we're using the positive square root of 20. And again, the reason it could be negative, because we took the square root, if you were to square this 2 square root of 5, then a negative times a negative would also turn out to be a positive 20. but in most cases we're usually going to be looking at the positive sign. All right, here we have another example, and we're given the two sides of our right triangle, and we want to find the other side. So down here, I'm just going to call this side x. So we want to find what is the value of x here. Now, if you notice this case, we're given the hypotenuse is 4, and then we're given one of the other sides. So if we use our formula, once again here, that is a squared plus b squared equals c squared. It doesn't matter which value for a and b. For the 3 could go in for either one of those. In this case, I'm going to say a, and just because I call this x, I'm actually going to say this is x squared. Okay, and then we would have plus b squared, and I'm going to use the 3 here, so that would be 3 squared. And then, of course, the 4 has to be our c squared, because the 4 is the hypotenuse. So we end up with x squared plus 3 squared equals 4. So if we go to solve this, then we would have x squared plus 9 equals 4 squared is 16. And if we subtract 9, we end up with x squared equals 16 minus 9, which is 7. And now we're at the same place we were before. This is x squared equals 7, and we need to find what does x equal. So therefore, again, we're going to have to take the square root of both sides. And again, that would be plus or minus the square root. And because we're talking about the length here, this would be a positive square root of 7. And of course, we could actually put this in the calculator. So you enter this in the calculator, then we could say x is approximately equal to 2.6. Okay, so you'll see that the square root of 7, this would be your exact answer. Okay, if you're looking for an exact answer, then we're going to leave it as a square root. If we're looking for an approximation, then we could put it in the calculator and come up with a decimal answer. And if we look over here now at the grid, we see that if we have 3 is on the y, 4 is our hypotenuse, and then along the bottom here, if we count here, it looks like we would have 1, 2, and then a little bit more than a half. So it makes sense then that here x is approximately 2.6. All right, our next example, here we're given 3 and 4. And I want to look at here, we're given this point here at the origin, so we know that would be 0, 0. And the point at the very top here of our triangle is 3, 4. And we could plug this into our formula to find the hypotenuse here, and I'll label that as x. So if we're looking for this variable, our unknown side here, we could certainly then say x squared, that's the hypotenuse, is equal to 3 squared plus 4 squared. And we would get x squared equals 9 plus 16. So we have x squared equals 25. And once again, we would have to take the square root of both sides. Keep it in mind, it would really be plus or minus. And again, because we're looking at the distance, we're going to use a positive 5. So here we have x is equal to 5. Now, really what we found here is we found the third side of our right triangle, and also realized we actually found the distance between the point 0, 0 and the point 3, 4. The distance between these 2 points is 5. And that's going to lead us into our next formula, which is the distance formula. And it states that if you're looking for the distance between 2 points, and let's see kind of how this relates to this problem, and you can see how this will relate a little bit to our Pythagorean theorem. Our distance formula says that d is equal to the square root of x sub 2 minus x sub 1 squared. Now let's see, what is that telling us? Well, that's telling us that if we take between our 2 points, now again up here, we can think of this as x1, y1, and 3, 4, we can label this as x sub 2, y sub 2. And again, the little sub numbers are just telling us that x1, y1, and x2, y2 are 2 different points. And we're subtracting x2 minus x1. Well, if we look at the graph up here, x2 is telling us this distance right here. Our x2 is 3. So that's telling us this point here is 3, and our y1 is at 0. So when we take 3 for x2 minus x1, which is 0, 3 minus 0, what is that finding? When we subtract, that's finding this distance. So we're finding the distance between here and here, which is 3, okay? So that's given us this part, and then we are going to square it, okay? And if you notice, this looks very similar to what we just did up here with the Pythagorean theorem. And then we're going to take and add this to y sub 2 minus y sub 1 squared. Now y2 minus y1, what is that finding? Well, our y2 is the 4, okay? So you're taking 4 minus our y1, which is 0. So that's going to give us this location squared. And you can kind of see how this looks like our Pythagorean theorem if we have c squared equals a squared plus b squared. And if I was to take the square root, c would be equal to the square root of a squared plus b squared. So you can kind of see the relationship here. A is representing the distance over here, and b is representing the distance here on the y. So we're squaring that, or subtracting x2 minus x1. That's really giving us our a value. y2 minus y1 is really giving us our b value. So this is kind of like our Pythagorean theorem. So we just set it up. If you're trying to find the distance between 2 points, is just going to be your x-coordinate subtracted squared plus your y-coordinate subtracted squared, and then you take the square root, and that will give you the distance. All right, so let's use this formula. Let's try that. So if we were given our point 0, 0, and we had our other point 3, 4, and again, we can just simply label this as our x1, y1. And it actually may help you if you write this in to see this so you don't make a mistake when you work these problems. So this would be x sub 2, y sub 2. So then if we're looking for the distance, then our distance is simply going to be the square root of x2, which is 3, minus 0, or x1 squared, plus y2, 4, minus 0 squared. And this is going to be pretty simple because we're going to end up with 3 minus 0, so that's 3 squared, which is 9, plus 4 minus 0, so 4 squared is 16, and we end up with the square root of 25, which equals 5. And if you notice, that's the exact same answer we came up with up here when we were using the Pythagorean theorem to finding our missing side. Because really we have found the distance between the origin and the point 3, 4. Now let's try that with another example. Here I already give us our points. We have the point 2, 0 and 5, 4. We want to find the distance between these 2 points. Well, again, we can't really count because we don't have nice blocks here. This is not going directly through each of our lines. And if you had a ruler, you could measure to find the distance. But we want to use our distance formula. And I'll write that down again for us. That is simply x2 minus x1 squared plus y2 minus y1 squared. And we're going to take the square root of all of that. So here, again, we can label and it doesn't matter which one we call x1, y1, or x2, y2. The one here at the bottom, I'm just going to label this as x1, y1. We certainly could have called it x2, y2. And up here, I'm going to call this one x2, y2. So once again, if we're trying to find the distance between these 2 points, we're going to take the square root of our x sub 2, which is 5, minus x sub 1, which is 2, that is squared, plus y sub 2 is 4, minus our y1, which is 0, squared. So we're going to end up with 5 minus 2, which is 3 squared, plus 4 minus 0, which is 4 squared. So here we get the square root of 3 squared is 9, plus 4 squared, which is 16. So once again, we get the square root of, whoops, should be 16, which is the square root of 25, and we end up with a distance of 5. Now, if you notice here, all I did was move these points over from the example I had up here before. If you notice, we came up with this right triangle. All I did here was move this right triangle over 2 places. So really, I moved, this is your translation here. We actually moved every point over 2 places. And we can see here, and if I was to make our right triangle, we would have our right triangle here, and we could certainly count 1, 2, 3. We have 3 here, and then up 1, 2, 3, 4. So we have our right triangle that has sides 3 and 4. So it's the same triangle, except for I moved it over 2 units. And I did that on purpose to show you that whether you're looking at here forming a right triangle, finding the missing side, or we're using the distance formula, we can still find, in this case, the length of the hypotenuse. All right, so from here you should know how to use the Pythagorean theorem. Keep in mind this only works for a right triangle. If you're given the 2 sides here that make up the right triangle, again, those are a and b, so that's a squared plus b squared equals the hypotenuse squared. And then, of course, our distance formula, if you want to find the distance between 2 points, is simply the square root of x2 minus x1 squared. So therefore, you're just simply subtracting your x coordinates, and then it's y2 minus y1 squared. You're simply subtracting your y coordinates.